Never lose the rubber. Always keep the rubber in there. See, a lot of technicians just throw this away. They don't care. Don't get rid of the rubber. Keep the rubber. Always use protection. I even had to convince a bunch of people here to make sure you keep the rubbers in the right spot, and they go back with the MacBook. They do actually serve a purpose. If this rubber's not here, you have all this hot air from the heatsink here, and it's just going to cycle right back in and blow hot air and blow hot air. It's not going to force it out of the machine. People argue tooth and nail on it that you don't need the rubber. Who cares about the rubber? It's just a stupid thing. Always pay attention to detail. No little detail like that is a stupid thing. This is your customer's device. It's not your device. Take care of your customer. If it's your device and you want to throw away that rubber, if you're not selling it, if you're keeping it and it's your device and you want to throw that away, more power to you. Go right ahead. But if that device belongs to somebody else, you have no right to not include that with the MacBook. You don't like rubber? Well, use lambskin then. Come on, Paul Daniel Software. Show me the page. You can do it. Maybe you can't. How's it going? So we have something interesting here today. I have a what's the number here? This is a 2159. This is one of the newer MacBooks, a 2159. So we've seen in the past month, I think this is number 10 around, number 9 or number 10, same exact problem. So I don't have a full working hypothesis on what's going on yet. I haven't sat and stared at the schematic long enough yet, but what I'm going to show you is the symptoms, what this thing comes in for, what it looks like, and what has been tested wrong with the thing. I don't know why this is happening yet. I need to stare at a schematic. Maybe somebody can help me out. Once you see all of this, open up the schematic, stare at it, try to analyze it. We got to figure out what's going on here. I think this might be some other Apple fail or something like that. Some kind of design failure. Use enough flux. No, use the right amount of flux, not enough, just enough, that's it. This is a year or two old. I think this is still current production. This is what's in the stores right now. Maybe not. This has the old keyboard. This is not a current model. This is a model back because it has the old butterfly keyboard. It's not the magic keyboard yet. So 2159 comes into the shop. This is number 10 in the last month. You plug it in. Seemingly nothing wrong with it. There's no liquid damage. There's no drop damage. Nothing going on with it. No foul play or anything going on here. Sometimes you get a quick fan spin, turn off, 200 milliamps, won't do anything. One of the things that we see a lot of times is DFU. So you would think right away this is a DFU, stuck in DFU mode, so you have to unlock it DFU, or restore it, or revive it. Don't restore, revive. Then you don't lose any data. But that's not the case here. So 200 milliamps, no turn on, quarter fan spin going on. So let's take this out. So we've already done all this diagnosis and everything. We've seen this a couple times. It took a couple of them to go through. We no-fixed a bunch of them before I put the thing underneath a thermal cam, and I poked around at one of them for a while because it was too many of them, too many of these models that we were no-fixing. And like, no, there's something wrong here. Something's going on. So I'm going to take this out of the case. I'll actually look over at chat every once in a while. So here's our board here. So what we found is that there's a 5-volt line that's up over here. It feeds the webcam. And this 5-volt chip here always gets hot under the thermal cam. So I'm going to bring that up on the schematic. This here is the LCD connector. Down over here, this is where the 5 volts is coming into the LCD connector for camera. So we got PP5V SO. No, this is panel 5 volts. This isn't camera. LCD power slew. Yeah, this is the 5 volts for LCD. Goes through the inductor, you got 5 volts for your LCD. Now this chip here keeps getting warm whenever you see this. You just power up the board and you'll have this chip getting hot. But this is a red herring. This is throwing you off from what's actually going on. Because we've tried replacing this chip and it didn't do anything. The board still stayed dead. The new chip got hot the same way. So what I did is I took this chip off and I put I injected voltage into the lines for the chip, the power lines for the chip. So this is PP5VGS3. So this is a CPU regulator miscellaneous. So this is the power rail for just miscellaneous things around the board. You see that it goes to a whole bunch of other stuff around the board. You got the MOSFETs that it controls. So when we were first looking through all this, we're like, oh great, MOSFETs, nothing seems to be working right. This is probably a dead CPU. So something's going on with a MOSFET or a CPU. We're not going to be able to fix this. But then I noticed that these chips down over here, where it's coming into, these guys, which I know my mouse pointer is in the wrong spot, but look at the flag instead of the mouse pointer. These guys here are shorted. Right here, if you put your probe here on both of these are the output of this chip. They're both shorted. This right here. Zoom out. Don't let one fool you either. We had that happen too, where we changed one, still nothing was working. This one here, same chip, different function. This one was dead too. So now let's take a look at these chips. Here, B-pillar trim is in the right spot, unlike Lewis. Yeah, I just I went out and took a look at that. Some of you guys might know that I used to be an automotive mechanic before this life. And yeah, I went and took a look at his B-pillar, and somebody was messing around with his seatbelt. So somebody was in there. I don't know if they changed the seatbelt or the seatbelt got stuck. Somebody had the B-pillar trim off, and they just slapped it up shoddily. And if any of you guys that work on cars knows that if you put it in wrong and then letting the car sit in the heat, it winds up deforming the whole thing so that it won't even go in right anymore. So I took the whole thing apart. I had to sit there and bend on some of the pins and stuff and hold them up for a little while so that they would like somewhat line up in the right position, and slapped it all back together. And the only thing that's not working is his seatbelt height adjustment's not working anymore. So he still needs to go to the dealership and have them work on his seatbelt adjuster. So where were we? We were looking at these chips. So let's take a look at this. So like I said, I don't know what's going on with this yet. I just know the result of it. I know that these chips die. I don't know what is causing this. We haven't looked enough into it. I need to stare at the schematic and board view and, click on all these pins all around it and see where they all go and try to figure out what is connected, what's going on, why are these things dying. I don't know why they're dying. I don't know if they picked the wrong chips or if too much to just guess on right now. But I need an engineer, a real engineer, to tell me why these chips are dying. So we take a look at it here. It's a ISL 95870. So it's an ISL like we all know. It's a buck regulator, but it's just in a different package. So we have a 5 volts coming in. Is my pointer doesn't show up at all. So I will highlight to show what I'm talking about. I can't even highlight. Paul Daniels, why can't I highlight? Yeah, I can highlight. Okay, there. I can right click on it and it highlights. So this is what we're looking at here. The 5 volts is coming into this here. So these are shorted. Right here, past the two resistors that are right here, the input to this chip, VCC, PVCC, these are shorted. This chip has died, and it's only the chip. This chip right here it takes the 5 volts G3S CPU regulator in miscellaneous to 1 volt EDRAM. So this is for one of the RAM chips on this, EDRAM. I think that's internal to the CPU. Yeah. EDRAM SO CPU. So this is a 1 volt 6 amp output that's going to the CPU just for the internal RAM of the CPU. So now if we take a look at the other one here, this one too, it's the same chip, different function. This one is creating 0.95 volts VCCIO. So VCCIO is for the CPU again. So both of these are going to the CPU, SO CPU. So let's see, where is the output? We can see the output. Okay, it goes through a current sense resistor. So it comes up here, let's see. Okay, inductor, this is the inductor, that's probably the MOSFET right there. Yep, this is the MOSFET, and it's all controlled by the chips that we're talking about on the other side. So the chip, this is a buck regulator. It takes 5 volts, and it turns it on and off a certain amount of times with the specific timing, so that on the outside here, with a couple capacitors, an inductor to smooth it all out, you get an average of, on this one, it's 0.95 volts. That goes to the CPU to power the I/O of the CPU, I believe. That's what the VCC I/O is. So this is power, the VCC power for the CPU for its I/O ports, probably internal USB or something like that. Not sure about CPU architecture that well. But so that's where it's going to. That's what this is all controlling. But there's nothing wrong with the output. The outputs seem fine. When you test all the outputs, everything seems fine with the CPU. It's the inputs here that's coming from the 5 volts that goes everywhere, the 5 volts miscellaneous. This is shorted. So let's take a look at this on the board. So what we're looking at here, zoom in some. This is your board. This is a new board, so anybody working on these things, you're going to see these. These are new. They're somewhat popular. So these are the 2 chips we're looking at, this one and this one. And the capacitors that are on either side of it, they're both facing different ways. So we look at this. This is going to be shorted. Dead short to ground. So I'm on a ground pad here, and right between, I wish it would stop focusing on my hand and focus on the board. It's not going to stop focusing on my hand and focus on the board. Focus. You fuck. There. Shorted. So this is supposed to be the 5 volt input to these chips through 2.2 resistors right there. Shorted. So now let's come over here to this one. I'll keep the same ground point, that's convenient. Shorted. This also affects the backlight driver a lot of times. It's been, I think, 5 out of the 10, or I think 7 out of the last 10, this backlight driver has been dead as well. So you can, most of the time we've replaced it, turned it on, oh, we have no backlight, then we find out the backlight driver is done. But for some reason it seems like the backlight driver is dying with both of these too. I don't know how it's related. I still have to, this is all supposition so far, we still need to dive into the schematic and figure this all out. So let's check that. So we can check that right here, I think it is. And that is good. Or maybe I'm supposed to be on the other side. That is dead shorted. Let me see what I'm looking at. I forget which one I'm supposed to look at here. So let's go back to the schematic and board view. Let's go over to the backlight driver. Here's our backlight driver. Okay, that is ground. Okay. LCD backlight feedback. This was it. Backlight sense out, or was it this one? Feedback. It was one of these. It's either the 201 or the 402 resistor. That's the sizes of these resistors. This one's size 201. This one's 402. One of these was shorted towards the chip, if it was dead every time. So that's a good test instead of having to turn it on. So that is the 201. That one is fine at 1 mega ohm. And this is the feedback. Feedback, we're wide open. No, we're charging capacitors. Yeah, we're charging all the backlight capacitors with the multimeter, so that is fine. So the backlight driver is good on this. A lot of times we see the backlight driver dead too. All right. So this is dead now, won't turn on. So what I'm going to do, we're going to change these two chips and bring this thing back to life. So we have brand new chips for this, but for anybody in the business that's working on this, you don't really need brand new chips. We just started ordering them because we're seeing so many of these. But these chips are all over every single board, all the way back to, I think I saw as far back as 2012, 2011 inch, 2011 11-inch air board. I found one of these chips on it. All the boards have these chips. Most of them only have one chip on it. This board has two, and it just must be the wrong chip. This is the only chip with GAY on it. Everything else is GAV or GA something else. So I'm wondering if this GAY, whatever the Y is in the GA, it must be a different designation for a different power handling or something like that. I don't know if they put the wrong chips in here and it's the wrong power handling, and that's why we're getting these things dying so much. I don't know if it's an update that's powering them wrong. I don't know what the backlight driver, or sometimes the camera on the screen will not work anymore. I don't know what that has to do with it. We really need to delve into it and see what's going on with it. Flux, who's got the flux? There's the flux. Okay, so I'm going to put the right amount of flux on this for removal. That is the right amount of flux for removal. I'm going to take my quick 861DW and heat this off the board. Some fume extraction would be good. Hello, my name is Tegan. No more flux. That is the right amount of flux. That's all you need. Just heat the whole area a little bit. Watch out for down in the bottom corner here because we got an underfilled NAND chip. So we want to heat away from the NAND chip. We don't want to heat that NAND chip at all if possible. If you're not that good with hot air, you should cover the NAND chip with something so that it doesn't get any residual heat. What am I at? 500 to 120. That's good. I'm going to take one of our new chips. We're going to replace the GAY chip for a GAV chip. I'm not sure what the breakdown of the model numbers mean. One of them is going to be probably current handling or frequency or something like that. But this is a fully compatible chip, the GAV. And let go. Thank you. Heat this back in place. Oop, nope, don't you go anywhere. Oop, stop it. There we go. Now that was a new chip on used pads. So usually we take a used chip and put it onto the pads. So you have an extra little bit of solder on a used chip. Like when you take a chip off a board, it takes some of the solder with it. So I took a chip off this board, I took some of the solder with it, and then I put a brand new chip on here that didn't come with any solder. So now you see that the pads are a little bit flat, especially on this side. Those pads are really flat. So I'm going to take a little bit more flux. Yes, I'm actually going to use some flux this time. I want to get it all the way around the chip. Perfect. I'm going to take my micro pencil, a little bit of solder, And we're going to just run some new solder around this to make those fillets properly. They're a little bit too light right now because we didn't have a chip with flux. We had a brand new chip on it. So just run that across there. Ooh, this micro tip doesn't look very good. Oh, I just combined that. This is a really small spot if I can't even fit the micro pencil into it. So now this is the real fillet I want to make, is this one. And I need to unshort that. Geez, this is a really tight spot. I didn't realize how tight this is. And this is not the best micro tip at all. Let's get some more flux in that. Okay, see, now I ran into troubles with the solder, so now I'm going to dump some flux on there like you all want to see. This micro tip will not pull solder. I'm going to have to get some goot wick in here. A little bit of goot wick. You should never use a micro pencil for goot wicking. But I'm just using the little corner of it, so it should be good. And okay. So let's fix this up. Kind of made of a mess of this one. It's just too tight. So let's put this capacitor back down, and this capacitor has to get unshorted from that. Zoom out a little bit, keep an eye on that underfilled chip underneath there. Make sure you're not blowing any flux to it. That's a good way of making sure your hot air is not going that way, that the flux isn't traveling to it. Hey. I have to be opposite-handed for this. That big capacitor is blocking me. I'm getting capacitor blocked. Well, this is really annoying. I don't usually have troubles like this. That's really annoying. There you go. So that's one down. We can take a look at that with the multimeter. – 28 ohms. So this is a 1 volt line at 6 amps. So that looks right. Now let's go over to the other one. There's the other one. And there's less sensitive stuff in this area. There's no underfilled chips anywhere. This one's a little bit easier to handle. Yeah, 1 paul of flux is about 1 pico-Rossmann of flux. That's a good measurement. Use the right amount of flux there. And you won't let go. Let go. Get down there. Thank you. More flux, more good. No, more flux, more cleaning. This is all you need right here underneath your work. It doesn't need to get run off into here. It doesn't need to run all the way over here. All you need is flux where you're working. Okay, again, we see the same thing with the solder. The fillets are not there. It's just flat pads because we took a chip off and put a brand new chip on. So we're going to have to make some fillets around this one too. You could avoid this by adding more solder to the pads too before you put the chip on. Let's see if this one's a little bit more accessible. Big capacitor is just totally in my way. There you go. There's only one fillet I don't like, this one. There you go. That's what it's supposed to look like. Yes, and that is how we turn a Mac into a PC. It is no longer a Mac. You cannot represent this to your customer as a Mac, because this has less of a chance of dying now. We put compatible chips on it rather than whatever they had on here. So this has less of a chance of dying. It will last longer, hopefully. So we cannot call it a Mac anymore, because it's not made for obsolescence. Once you take out its obsolescence, it's not a Mac. Then you got like a Lenovo, once it doesn't have built-in obsolescence. Oops, was I supposed to say that? Am I speaking out of turn? Is that so mean? Let's do a little bit of cleanup. Same with the right amount of flux. All it takes is a little bit of Q-tipping. I don't have to put this board in the ultrasonic cleaner just because I changed 2 tiny little chips in it. Look at how small this is. That's a Q-tip, standard Q-tip. Everything is tiny here that we work with. Ooh, and in cleaning, I see something that might be an issue. While working on this side, I must have thrown a solder ball. There is a solder ball that is bridging some stuff. Oh, no, it's not bridging. But it could, possibly. I am getting that out of there. I do not like seeing that laying around. Ooh, I need a smaller... That worked. Start campaigning against micro components. We don't need ultra-thin devices. No, I don't want to see through hole. I don't want to see giant resistors on this. That's backwards thinking, like the UK with their, you're only allowed to use micro USB for your chargers. We want a standard micro USB, none of this USB-C crap. No advancements. USB-C carries 5 times as much energy and 10 times as much data throughput, but no, we don't want that. I'm all for standard stuff and everything. I hate the stupid lightning port, but you gotta stay with the times. Everything should be USB-C by now. except laptops. I don't think laptops should charge over USB-C. That's a dumb idea. Why do my messages stop? Sorry, this is a dumb or redundant question, but what soldering iron do you all use? The FX951, yes, this is basically the FX951, but this is the double version of it. This is the FM203 that we have here. It's the same thing as the FX951, only it has 2 handpieces on it. I think, let's go to the overhead real quick. Can I turn this enough to see it? Yeah, you can see it there. This is the FM203, and it supports 2 handpieces, both of them with sleep, so that it doesn't even turn on. Well, it keeps it hot, but it's not hot. It's not soldering hot yet until you pick it up, and it turns it off, so it saves your tips and everything. So we have the, what is this, the FM2027 regular tip, regular handpiece with the large tip. I forget what that is, something like the 13 or something like that. That's the chisel, the regular chisel tip. Sometimes we use the one with the little solder well in it. It's a chisel, flat tip with a little solder well inside of it. And then the micro handpiece, FM2032, and this is the KN, what is it? T30KN micro tip. So you don't have to buy the big one. This big one's expensive, but you really should have both of these handpieces. And this is the stand for tweezers, and all you have to do is just put a stick through them, and it'll hold the micro handpiece just fine. So if you want to use the tweezers go on this tip, and then it also adapts easily to the micro handpiece. But yeah, you can get just the FX951 instead of this big one, and then just have 2 tips that you just have to unplug and plug back in whenever you use them. Because you want both of these tips for working on stuff. You don't want to have to... this tip would never fit in the chip that I was just working on. And then something like larger MOSFETs and stuff like that, this is not going to do anything for it unless you preheat it with the hot air. So that's those 2 chips, there and there. We looked at the backlight driver. The backlight driver is usually an issue with this. This was not this time. Backlight driver was fine. So let's go ahead and put it back in its shell and see if we've solved this problem. We haven't solved this problem. We've patched this problem. I really need to solve it, see why this is happening. This is very initial stages of identifying a systematic failure. This is happening. It's too many. It's not a coincidence. This is too many of them in too short of a period too. So I'm wondering if it was an update. Did an update enact something wrong? Did it turn on wrong after the update and kill all of these? Because it's all of a sudden. These are a year-old machines, something like that, and they're all dying all at the same time. So it's very, very, very interesting. It's the normal conspiracy level bullshit that Apple has. Why are you not plugging in? Why are you not plugging? There. Okay, we're good. Never lose the rubber. Always keep the rubber in there. See, a lot of technicians just throw this away. They don't care. Don't get rid of the rubber. Keep the rubber. Always use protection. I even had to convince a bunch of people here to make sure you keep the rubbers in the right spot, and they go back with the MacBook. They do actually serve a purpose. If this rubber's not here, you have all this hot air from the heatsink here, and it's just going to cycle right back in and blow hot air and blow hot air. It's not going to force it out of the machine. People argue tooth and nail on it that you don't need the rubber. Who cares about the rubber? It's just a stupid thing. Always pay attention to detail. No little detail like that is a stupid thing. This is your customer's device. It's not your device. Take care of your customer. If it's your device and you want to throw away that rubber, if you're not selling it, if you're keeping it and it's your device and you want to throw that away, more power to you. Go right ahead. But if that device belongs to somebody else, you have no right to not include that with the MacBook. You don't like rubber? Well, use lambskin then. Okay, let's see what we got. Can you see that? You can see that. You can't really read that. So I got 20 volts, I got 150 milliamps, 400 milliamps, 500 milliamps, and hopefully this doesn't go straight to the boot screen. I just had a chime, and I have no backlight. Aha! See, standard issue. I have no backlight. I do see an Apple logo in there. You guys can't see it. I don't have of Apple to shine it through anymore. So, standard issue. Even though that tested okay, it seems like it's related with the backlight too somewhere. I don't know how this all fits together. I haven't figured it out yet, but somehow this is happening. The backlight goes out, it takes out the two gay chips. Either that or the two ISLs go out and it takes out the backlight. Either that or it's something to do with the screen, possibly. That's another course to look at. We need somebody to analyze all this crap. Connector? No, that wasn't the connector. This connector either engages or doesn't engage. So, let me go find a backlight chip. These are getting rare in the shop because this is a new backlight chip. We cannot find it on the market yet. I am going to have to find a board that I could get it off of. One moment, please. We are running really thin on these backlight drivers, and I don't know if this is a 2141 board. I don't know if this is the right one. I have to see. Let's see, what number are you? You are 48B1. And the one I need is 48B1. All right. Let's go. So, microscope. So here's our backlight driver. Go ahead and take this guy off of here. Should I swing by and grab some Bondi sushi before I stop by Sunday? Also, hi, Paul. Hi, Christopher. I don't know who's here on Sunday. I stopped working weekends a long time ago. I think it's Hi, Shane, possibly? David, the iPhone guy. It's a small crowd on Sundays. Sonny, what's up, Sonny? Sonny, you have to buy Lewis's broken Tesla and fix that. I guarantee you it's not. You got to look at the underbody and see how bad the linkages and the steering and all that stuff. Just the frame mount, where the control arm goes to the frame. You have to see how bad that is. If the frame is okay, then that thing should be easily fixable. It's just going to be a parts problem. Where do you get parts for that? I guarantee you that's why the cost is so expensive. The cost to repair. Because it's just the Tesla parts. Tesla's charging a ridiculous premium for their parts. Because that should not be that expensive to fix. Oh, look at that. This is interesting. You don't see this very often. This cut-off corner in the ground pad there, that's actually an indication for pin 1. And some engineer at Apple probably lost their job because they left that in there. Because they don't want to help anybody with anything. Because I don't think the computer reads that. The computer knows what the orientation is. They don't need to see a cutout That's for people reworking, that you would have a cutout for pin 1. So now I take my new chip and I see the dot's right there, so that's pin 1, and I line up pin 1 with my cutout there. Yeah, so somebody at Apple got fired for leaving that in. Let me get a little bit more flux on that. It's not a problem. You can get it from a rental. What are you going to do? Rent a Tesla and just take everything off of it and then return it back? That's insane. That's some Chinese scamming for you right there. Don't do that. Too much coffee today. Oop. I do not like how that chip went on there. I'm going to put more solder on those pads. Do I play chess from time to time casually? I'm not any good. Never really took to the game that well. There, now our pads are nice puffy little pillows. You get a little bit of solder on that ground pad in the middle there, and it will help the chip to float right in the middle. And it will basically self-align itself onto all the other pads. It just dances itself right in the middle, give it a little tap down, get some solder blobs out the side. Now let it dry. I'm going to hold it down, straight down in the middle, heat it back up, let go. There you go. Now we'll get those solder blobs out of there. Okay, new backlight driver now. Now let's do this again. So the backlight driver came off of a 2141. So that's one of the newer machines. It's a newer backlight driver. We need to find more of them. Let's give this a little bit of Q-tipping so I don't have to take it back out later. I could just put this thing together if this works. You broke a SATA connector on a hard drive. Should I try to fix it or send it to Paul? If you're okay, or if you have a hot air station and you're somewhat okay with soldering, it's not that bad to fix it yourself. You're not going to fix the SATA connector. Fuck that. You're not going to put a new SATA connector on. What you do is find a donor board or find a whole donor drive for your drive, on eBay or something like that, or there's donor drives or something like that. There's a bunch of sites that sell donor drives. And you're going to take the... Oh, that was not my tweezers, and they were full of flux. And you're going to take the board off of the donor drive, and you need to locate the BIOS chip off of there, the ROM chip, and you're going to transfer your ROM chip off of your broken drive to your donor drive board, and then put the donor drive board on your drive, and you should be fine. It'll work just fine, and it'll work like that forever. Just don't overheat anything, and, practice on something. It's just a little 8-legged chip that's on there. Pretty easy to take off and put on. Just make sure you find the right board for your drive. And if you want us to do it, we could do it. We could send it in here. We have a lot of boards in stock here. We could do that for you. Steve answered questions about which drives are worth sending. What do you mean on which drives are worth sending? Like, to fix? I mean, any drive is worth fixing if you need the data off of it. The drive isn't the question, it's the data on the drive. I would never take a faulty drive, except for something like that. Like, I was putting it in and I slipped and I broke the SATA connector. Okay, you can still trust that drive to work. But if your drive has failed, if it has developed bad sectors, if it has done anything out of the ordinary, I would never fix the drive to use for data again, to use in your system again. Just buy a new drive. Drives are cheap. Your data is not replaceable. You can replace a drive. You can't replace your data. If you don't have a backup, then you're done. If you don't have a backup of your backup, you don't have a backup. Okay, let's see if we got backlight this time. That's really hard to read on the screen, isn't it? 20 volts. We got 100 milliamps, 160 milliamps, 400 milliamps, 500 milliamps, and we should have Apple logo. I got chime. I just heard the chime. And I don't see anything yet. We don't have backlight. So it was not the driver that's causing no backlight. It was something else causing no backlight. Very interesting. Actually, let me see what voltage we have on backlight. Am I on? Is the screen on? I can't see through all the yuck on this screen. Let me get a towel. Okay, I have a login screen there. So I am in an OS. I should have backlight. I have 0. So adjust the backlight. This is a non-adjusted backlight. Like if you had low backlight, you should have something like 20 volts on backlight. We have 0 on backlight. But I don't know, that's the old OS. Maybe it's different now. Here's the touch bar is working. I'm hitting backlight up. I'm getting no backlight. So I could make out the login a little bit. So we have no backlight. Do we have a short on backlight? That is definitely not shorted. Let's check the soldering of that chip. Maybe I left something off. Maybe this is indicative of the whole problem. Maybe it's something wrong with the backlight that's causing this whole entire thing. That's why the backlight chip is dead and both of those ISLs are dead. Maybe I should get a test screen instead of using their screen every time. Let's look at this first and then I'll go get a test screen instead. So now I want to look at sideways. I want to look at all of the fillets of solder. These are terrible because the pads don't actually go around, but you can kind of see that the pads are underneath it. They're connected. Those are definitely connected well. That one's hard to see because of the placement. Let me bring it over the edge of the table. They are connected well. On the last side. That is connected well. Pin 1 is in the right spot. Everything around it is proper. Let me get a test screen and I'll get another board with a backlight chip on it too, just in case. Do I have any kitties? No, I don't have any kitties. I have turtles. I have 4 radiated slider turtles at home. Okay, so I brought a test screen. So first I'm going to rule out that their screen is good or bad with a test screen. This is a screen off of a 1706 or 1708. Will also work with this. Oh, I need a test charge port. And I brought another board too, just in case I want another backlight driver. Let me go get my test port. My test port created this out of one that was junked. Cleaned up the pins. I put some hot glue on the edges so it's easier to handle. It's been around with me for a while now. Okay, so now we're going to rule out their screen. So it's turning on. 140 milliamps, 500 milliamps, and we have backlight. We have Apple logo. I'm not letting it boot all the way. So yeah, they have a bad screen. So that's something else we were speculating on, is that something's wrong with the screen that's feeding back into backlight, that's feeding back into this 5-volt rail that's killing the 2 ISLs. The backlight chip is on that 5-volt rail that the ISLs are on. But there's so many other things on there, I don't understand how only those ISLs are dying, unless they're just wussy chips. But they're on other machines, but the GAVs are on other machines, not the GAYs. So I don't know if the GAYs they can't handle the right current, the GAVs are a higher current rating. I don't know. This is something that we have to sit and research for a while. Or somebody that actually has a degree in this, because I sure as hell ain't got no degree in this. Take a look at why are these boards failing like this? Why is it that both of these chips fail? This is number 10 out of the last 3 weeks now. I don't know if it's an update that did it. That's why they're all coming at the same time, because these things have been out for a year or two now. This is a 2019 or 2020. I think it's a 2020 machine. I don't know. No, it still has the butterfly keyboard. I'm not sure when it is. Don't quote me on that. But yeah, so it needs a screen. It's going to need a whole screen assembly because it's the backlight. Either that or maybe the screen board. We can take a look at that, disassemble that. Not sure. But anyway, I hope you learned something. And if you're in the business and you get these machines in completely clean, nothing wrong with it, seems fine, only it's not turning on. You get quarter fan spin sometimes. Sometimes you get only 150 milliamps and it just doesn't turn on. Take a look at these ISL chips. The two, it is U7710 and U8110. So both of those chips, they die. Most of the time the backlight driver is dead too. I think there's only one time so far that the backlight driver was not dead. This may have not been dead because the screen was dead. So that backlight driver I took off, that might still be good, since it's tested good too. I should probably keep that then. But I hope you learned something. Happy hunting.